If you remember in our previous presentation, we had seen how to add two numbers without using plus operator. At the end, I gave you one homework problem in which we were required to incorporate negative integers to our code. As you already know, our code was not compatible for the negative integers. Now, it's time to consider the solution to that homework problem. Here is the solution to that homework problem. Here you can clearly see this particular piece of code is exactly equal to the previous code, right? Here I'm checking if y is greater than 0, then we will increment the value of x and simply decrement the value of y, right? If y is not equals to 0, right? And if y is less than 0, we simply decrement the value of x and increment the value of y, and of course y should not be equals to 0. Why we are doing this? Let's understand this with the help of an example. Here suppose we have x equals to 2 and y equals to -1. Now, if we try to add these two numbers, x and y, the output must be 1, right? As you can clearly see, y is -1, which means y is less than 0. We simply need to decrement the value of x and we need to increment the value of y so that y becomes 0 and x becomes 1. And that is what we wanted, right? And if y is greater than 0, we will simply increment the value of x and decrement the value of y. Let's see whether this program works fine or not. Let's say we have two values, 2 and -1. Output must be 1. Yes, sum of two values is 1. Let's consider one more case. This time, let's say we have -2 and 1. Output is -1 as expected. So this is also correct. Let's consider one more case. -90 and -80. Sum must be -170, right? Yes, sum is -170. Therefore, we can clearly say that our code works fine for every integer, right? Now, as we know, we need to write a program which add two numbers without using plus operator. We had already seen one solution in which we can add two numbers without using plus operator, but here we will use a different idea. The idea is to use half adder logic. We will simply use the logic of half adder in order to add two numbers. But before diving deep into the code, let's first understand some basics behind half adder. Half adder is basically a combinational circuit which takes 2 bits at a time and produces 2 bits output at a time. One bit is considered as a sum bit and the other bit is considered as a carry bit. Let's consider the truth table. Here you can see I have provided all the possible combinations of A and B, right? That is 0, 0, 0, 1, 1, 0 and 1, 1. Now what we will do, we will simply add these 2 bits at a time and let's see what would be the sum and what will be the carry. 0 plus 0 is 0 and carry will be 0. 0 plus 1 is 1 and carry is again 0. 1 plus 0 is 1 and carry is again 0. 1 plus 1 will be 2, right? Which in binary is represented as 1, 0. 1 will be considered as a carry bit and 0 will be considered as a sum bit. Now if you observe this particular truth table carefully, then you can clearly see that S is nothing but A XOR B. Because whenever we are having two different bits, the output is equal to 1. So we can say that S is equals to A XOR B. And what will be the carry? C is equal to A and B because when we have 1, 1 as our input combination, the output C is equal to 1. Therefore, carry will be A and B. We will simply use these two equations in our code in order to calculate the sum. Here is our code in which we are trying to add two numbers without using plus operator. If we carefully observe, we are not using any plus operator at all, right? Here if b is equals to 0, we come outside of this loop. Otherwise, we come inside this loop. Sum is equals to a bitwise XOR b. This is bitwise XOR operator. Then after that we have carry equals to a bitwise and b. And we are also performing left shift by 1. After that, We simply store sum inside A and carry inside B. And we continue to loop around till B becomes 0. In order to understand this code in a better way, let's consider one example. Suppose we have two numbers 5 and 10. Binary representation of 5 is 0101 and for 10 it is 1010 if we are considering 4 bits only. Okay. Let's try to add these two numbers and see what would be the result in binary. 1 plus 0 is 1, 0 plus 1 is 1 again, 1 plus 0 is 1 again, and 0 plus 1 is 1. Therefore, this is the binary combination which is equivalent to 15 in decimal, right? Let's consider A is equals to 5 and B is equals to 10. As B is not equals to 0, therefore we can come inside this while loop. Let's see what we get in the iteration number 1. Sum will be 1, 1, 1, 1 because we are performing bitwise XOR between these two numbers. 1 XOR 0 is 1, 0 XOR 1 is 1, 1 XOR 0 is 1, and 0 XOR 1 is again 1. Therefore, sum will be 1, 1, 1, 1. And what will be the carry? 1 and 0 is 0 only. 0 and 1 is 0. 1 and 0 is 0 and 0 and 1 is 0. Therefore, carry will be 0, 0, 0, 0. Right? If we perform left shift by 1, then also we will get the same combination. Right? Now we will store this latest sum inside A and this latest carry inside B and check if B is equals to 0 or not. As B, which is our carry, is equals to 0, therefore we come outside of this while loop and we will simply print this sum, which is 15 in decimal representation, right? Let's consider one more example. Here suppose we are considering two numbers, let's say 7 and 2. Binary representation of 7 is 0, 1, 1, 1 and 2 is 0, 0, 1, 0. 1 plus 0 is 1. 1 plus 1 is 1, 0. Therefore, 0 will be at the sum and 1 will be at the carry. 1 plus 1 plus 0 is again 2, which is equals to 1, 0 in binary. Therefore, 0 will be at the sum and 1 will be at the carry. 1 plus 0 is equals to 1, right? Therefore, the final output is 1001, which is equals to 9. Let's say A is equals to 7 and B is equals to 2. And let's try to execute our code. In the iteration number 1, sum will be A XOR B. That means 1 XOR 0 is 1, 1 XOR 1 is 0, 1 XOR 0 is 1, and 0 XOR 0 is 0. Therefore, sum will be 0, 1, 0, 1. And what will be the carry? Carry is 1 and 0, which is 0, 1 and 1, which is 1. This is 0 and this will also be 0. Therefore, carry is 0, 0, 1, 0. As we can clearly see, carry is not equals to 0. So we need to consider the carry, of course. But if you observe this carefully, we are adding carry at third position and not at the second position. But here, we are having carry at the second position. We want to add this carry to our sum. But if we add, this carry will be added to the second position and not to the third position. But we need to add it to the third position. Therefore, we need to shift this binary number towards left by one position. That is why we are doing this operation, right? So this will get shifted towards left after performing this operation. That means it becomes 0, 1, 0, 0. Now we know what will be the next step. This latest sum will get stored inside A and this latest carry will get stored inside B. Now, in the iteration number 2, we will simply add these two binary numbers, right? So 1 XOR 0 is 1, 0 XOR 0 is 0, 1 XOR 1 is 0, and 0 XOR 0 is 0. Therefore, sum will be 0, 0, 0, 1. We are halfway around in our calculation, right? We want 1, 0, 0, 1 and right now we are getting 0, 0, 0, 1 because we have not added this carry yet. Now we need to add this carry to our sum. Let's see whether we would be able to obtain the carry or not. Now we need to perform bitwise AND between these two binary numbers. The result would be 0, 1, 0, 0. You can easily check that, right? As you can clearly see, 1 is in the third position, but we want 1 to be in the fourth position. Therefore, we will shift this particular binary number towards left by one position. So the output becomes 1, 0, 0, 0, right? And we know this latest sum will get stored inside A and this latest carry will get stored inside B. In the next iteration, we will perform bitwise XOR between these two binary numbers. As 1 XOR 0 is 1 and 0 XOR 1 is 1, therefore what we are getting as a sum is 1001, which is equal to our actual result, right? And that is what we wanted. And carry becomes 0000 because 1 and 0 is 0 and 0 and 1 is also 0. Therefore, carry is 0000. This sum will get stored inside A and this carry will stored inside B. As B is equals to 0, therefore we come outside of this loop and simply print the sum, which is 9 in decimal. Now you can clearly see how this code works for these examples, right? Let's consider one more example in order to cement this concept. Now let's say we have two numbers 7 and 7. We know the sum must be 14. 7 is represented as 0, 1, 1, 1. Now let's add these two numbers. 1 plus 1 is 0 and carry must be 1. 1 plus 1 plus 1 is 3, right? Which in binary is represented as 1, 1. Therefore, 1 will be at the sum and 1 will be at the carry. 1 plus 1 plus 1 is again 1, 1 and 1 plus 0 is 1. Final output is 14, right? This binary number can be represented in decimal as 40. Let's execute this code for these two numbers. A XOR B is equals to 0, 0, 0, 0. Because 1 XOR 1 is 0, this is also 0, this will also be 0 and this is also 0. Therefore, sum will be 0, 0, 0, 0. And what will be the carry? Carry will simply be 0, 1, 1, 1. You can easily check this. If we shift this binary number towards left by 1 position, then this will become 1, 1, 1, 0. And you know what we need to do in the next step. We need to perform XOR between these two binary numbers. So in the iteration 2, we will get sum as 1, 1, 1, 0. Right? And what will be the carry? Carry will simply be 0, 0, 0, 0. Because 0 and 1 is 0, 0 and 1 is 0, 0 and 1 is 0 and 0 and 0 is 0. Now B will contain 0 and A will contain the sum 1, 1, 1, 0, which is equals to 14. As B is equals to 0, we come outside of this loop and simply print 14 as our result. Here in this example, if you observe it carefully, we have 3 carries, right? And we are getting carry in the first iteration itself. We will simply add this to our sum and we are successful in obtaining our sum in the second iteration. And this time carry becomes 0. It has to be 0 because this is our actual sum. And that is what we are obtaining through this code, right? Therefore, this code works fine and mimicking the behavior of half adder. Now it's time to execute this code. Let's see what will be the output of this particular code. Let's say we want to add 8 and 9. Sum must be 17. Yes, sum is 17. Let's say we want to add minus 9 and minus 8. Sum is equals to minus 17. This is what is expected, right? Let's say we want to add minus 7 and 90. Sum is equals to 83. This is correct. Therefore, we can say that our code works fine and add two numbers without even using the plus operator. Okay friends, this is it for now. Thank you for watching this presentation.